What if I told you there's a secret language that powers literally everything you do online? No, it's not English, and it's not the programming code you see on a screen. It's something much more fundamental. And today, we're going to learn it. So, what is this secret language? Understanding it is the very first step to becoming a kind of digital detective, someone who can actually see how information moves, and, more importantly, how to keep it safe. Well, it's not English or French or even emojis. The language that computers speak is way, way simpler. It's built on just two symbols, a 1 and a 0. That's it. Seriously. And this system, it's called binary. It is the universal language for all digital stuff. Every photo you take, every song you stream, and yep, even your most secret passwords are at their core just long, long strings of ones and zeros. So if you want to protect that data, you've got to speak its language. So, how do we learn to speak binary? You might be surprised, but it's actually super simple, and the key is, well, it's literally at your fingertips. See, we humans usually count in a system called base 10, probably because we have 10 fingers, right? Well, computers are much simpler. Just think of them as having only two states, on, which we'll call a 1, and off, which is a 0. This simple idea is the foundation for everything they do. Okay, let's actually try this together. Hold out one hand. Each of your fingers represents a value, and it doubles as you go along. Your thumb is 1, your index finger is 2, the middle is 4, ring is 8, and your pinky is 16. If a finger is up, you count its value. If it's down, it's a 0. You just ignore it. All right, you're ready for a quick challenge? Using that system, try to show me the number 21. Which fingers do you need to hold up? Go ahead, I'll give you a second to figure it out. And got it? Let's see. You should have your pinky up for 16, your middle finger up for 4, and your thumb up for 1. 16 plus 4 plus 1 equals 21. See? You're already thinking like a computer. Now let's find out why this is so critical for cybersecurity. Okay, so that little counting trick isn't just a game. It is the absolute foundation for how the entire internet is organized. Let's talk about the internet's address system. Think about it. Every single device connected to the internet, your phone, your laptop, a giant web server, it needs a unique address so data can find it. This is called an IP address, and it works exactly like a house address does for delivering mail. Now, a standard IP address is made of 4 numbers, right? All separated by dots. Each of those numbers is created by a group of 8 bits, 8 of those ones and zeros. This group of 8 has a special name. It's called an octet. It's basically like counting with 8 fingers instead of just 5. So, quick question. If you had 8 fingers to count with in binary, what's the highest number you could possibly make? The answer is 255. This is exactly why you'll never ever see a number higher than 255 in a standard IP address. The whole address system for the internet is built on this simple binary limit. And this is where cybersecurity really comes in. Security professionals use their understanding of binary to read these IP addresses in their raw form. This lets them spot suspicious activity, build firewalls, and block attackers. It's all about understanding the ones and zeros that make up the map of the internet. All right, so we've moved from counting to addresses. Now, let's talk about secrets. Because binary isn't just for organizing information, it's also for hiding it. Let's dive into encryption. We're going to look at a fundamental tool called XOR, which is short for exclusive OR. The easiest way to think about it is like a simple digital lock. It can scramble any message you give it, turning it into total nonsense for anyone who doesn't have the key. The rules are ridiculously simple. You ready? If 2 bits are the same, the result is 0. If they're different, the result is 1. That's it. Same equals off, different equals on. That simple logic is behind this incredibly powerful encryption tool. So here's how it works. You take your message in binary, and you have a secret key, also in binary. Then you just apply that XOR rule to each pair of bits, one by one. 1 and 0, they're different, so the result is 1. 0 and 1, different again, so another one. 1 and 1, they're the same, so the result is 0. You just do this all the way down the line. And what happens? Well, your secret message is now completely unreadable gibberish to anyone who doesn't have that key. But here's the magic part. If you do have the key, you just run the exact same process again, and it unscrambles it perfectly, giving you the original message back. This is one of the basic building blocks of modern encryption. Okay, let's bring this all together. Learning this stuff isn't just some abstract exercise. What you've just done is basically gain a digital superpower. You now get that binary is the language of your data, it's the blueprint for the internet's map, and it's the key to making digital locks. This isn't just theory, it's the actual reality of how our digital world is built and how it's protected. So the key takeaway is this. Binary is the absolute bedrock of our digital world. Really understanding these simple ones and zeros gives you a huge advantage, whether you want to build the next great app or you want to be the one stopping the next major cyber attack. So you've just learned the secret language of computers. The only question left is, what are you going to build or what are you going to protect with this new superpower? Thanks for joining this explainer.